All right, good morning, good morning, good morning. Thanks for waiting while I was passing stuff out. A lot of stuff to hand back today, but it happens. Okay. One new thing for the next few months. And really, it's not that huge of a change for you guys, but in the educational field, there is something called an SLO. And teachers are required to do an SLO every year. SLO stands for Student Learning Objective. This year, Wausau West, as an entire building, also has to do an SLO. So individual teachers have to do one, the building has to do one. And so this year, it's a math building-wide SLO. And so what we are going to track and get some data behind to see how we can improve on it is being absent from class, how that affects your grade. Okay? And going into the resource center and how that affects your grade. And things of that nature. And so to get some data behind that, for each chapter, from now until basically the end of third quarter, we're going to have to fill out this sheet. And I'll keep the sheets in here. I'll hang some folders on the backboard, and so you can fill it out 2 minutes before, at the beginning of each class. Fill it out from basically the last day or the last 2 days if it was a Wednesday. And you're just making tally marks, really, until you get to the end of the chapter. The first 2 questions you can't answer until the end of the chapter. Topics in a chapter that I felt good about, topics in a chapter I did not feel good about. We'll talk about that. Okay? But then here is where you're going to just start making tally marks. So each day, you're going to fill out your sheet, and then you're going to say, all right, yesterday I went into the Resource Center for 2 mods of fact scheduling, so you'd make 2 tally marks underneath that third question. But then I stayed for an extra mod. So you would have, another tally mark down at the bottom, or on the next one. Okay? And then a couple of more questions. Number of mods spent with a special education teacher, that may not apply to you, that may apply to you. Okay, so we put that one on there. Number of times you accessed It's Learning. So if you went on It's Learning the night before, you'd put a tally mark in that one. Or if you went on at school to check out the homework, and then went on at home because you wanted to check the homework or something like that, you would make 2 tally marks or something like that. Number of questions asked in class. So if you asked a question the day before, you could put a tally mark there. Okay? Number of mods you were absent, including conflicted mods during the chapter. So if you had to leave early for a mod and a half, you would put 1.5 there, kind of deal. So we're kind of tracking all this stuff. And then at the end of the chapter, then we'll total all of those tally marks up. And then after we get done taking the chapter test, then I would give you time to go fill out the Google form that goes along with it. So it's, again, very minimal, very uninvasive type stuff.
Did it also include a formative test too?
So for you guys, yes, it would. If you went in to take the formative in the Resource Center, how many that would include going into the Resource Center, yes. Okay. Okay. We're not going to start that now because we're mid-chapter. So next week when we finish the chapter, then we'll start this when we're done with that. So, okay? So, today we're actually going to take a step back in terms of the book, but where we're at, it's a step forward. Okay? Because we're in chapter 5, but we're going to take a step back into section 4.6. Excuse me. And we're going to talk about complex numbers. Okay? Complex numbers come in 3 different forms. Okay? Or we can rewrite numbers 3 different ways and make them all be complex, or 3 different kinds of numbers can be written in the complex way. Okay? The main thing, the reason that we have to learn complex numbers is because now we will be able to find all of the zeros. Up to this point, I've only asked you to find the real zeros of a function. Now, we're going to be able to find all of the zeros. Okay? So, let's talk about complex numbers. You learned these back in the A2, back in the Algebra 2. A complex number is of the form A plus BI, where the A is the real part and the BI is the imaginary part. Any number can be written as a complex number. Okay? So, for instance, we could write a complex number as a complex number. Now, you may be saying to yourself, well, duh, Linz, of course you can write a complex as a complex. So, an example of a complex number would be 3 plus 2i. That is a complex number. A real number written in complex form would be like 6. I can write 6 as a complex number, and then I would have to write it as 6 plus 0i. An imaginary number can be written as a complex number. An imaginary number like 2i could be written as 0 plus 2i, and then it's a complex number. The reason that I bring these up to you is because sometimes, if it's a real number, I would just want 6. If it's an imaginary number, I would just want 2i. Right? But if it's a complex number, like some of them might be complex this evening, I'd want it written as 3 plus 2i or 3 minus 8i or whatever it becomes. But just know that we can write all of those as complex. Okay? Now, the bedrock principle, the foundation for this section, why we're doing what we're doing, the foundation of this is the fact that I squared is equal to -1. If I squared is equal to -1, then I is equal to the square root of -1. You did a lot back in Algebra 2 of simplifying, whoops, tap the brakes. Yeah, hey now, there we go. Fat fingers, okay? Of simplifying using I. Why is that? There we go. Now we're back into it. There we go. Now it looks better. Simplifying using I. Okay? And so what you did is you said, well, we can't have the square root of -49. Oh, no. We can't have that because we can't take the square root of a negative number. So in order to do that, we said, well, this is the square root of -1 times the square root of 49. And we said, oh, yeah, we can do that because the square root of -1 is I, and the square root of 49 is 7. So the square root of -49 is 7i. When we're writing imaginary numbers or complex numbers or real numbers in complex form, the number comes first, the I comes last. Unless there's a radical involved. If there's a radical, a square root or a fourth root or whatever, okay, if there's a radical, then it goes number, I, radical. Okay? But number comes first, I comes second, radicals come last. Okay? So if I'm simplifying 2 times the square root of -32, I would say to myself, that's going to be 2 times the square root of -1 times the square root of 32. And then I'm going to ask myself, what's the biggest perfect square factor of 32? Remember, you have a list of perfect squares somewhere in your notes. Will be very helpful for you when we're simplifying with I. That list again was 1, 4, 9, 3, 16, 25, 36, 49, 64, 81, 100, and so on and so forth. 121, 144, 169, and so on and so forth. 196, 225, 16, what's 16? 256, 17 is 289, 18 is 324, I think.
Biggest square is 25.
Biggest square that goes into 32? But it's got to go into 32. 25 does not go evenly into 32. It's the biggest one smaller than 32, but it doesn't evenly divide into 32. You come up with it yet? What's the biggest perfect square factor of 32? You guys should know this one because square root of 32 is a common test question type, homework question type one. So if you don't know the biggest, give me a perfect square that goes into 32 then. 16 goes into 32, right? How many times? Twice. So that would be the biggest one then, right? Okay. So this would become the square root of 16 times the square root of 2. Okay. Well, what's the square root of -1? I. What's the square root of 16? 4. Now, if a number is on the outside, it can be multiplied with other numbers on the outside. So that would give me 8, 2 times 4, times I, times, then I still got the square root of 2. So I have all of my parts, but I can combine the 2 times 4. Okay. Now, why do we do this stuff? Well, let's talk about this algebraic equation here. Let's solve this. Okay? How would we go about solving this? X squared plus 6 equals 0. Subtract 6 first. Okay? Subtract 6 from both sides. That would give me then x squared equals -6. And now what would I do? Square root both sides. Okay? So if I square root the left side, what do I get? The square root of x squared. X. Okay. On the other side, I've got the square root of negative 6, which is the square root of negative 1 times the square root of positive 6. Are there any perfect square factors that go into 6? Nope, there's not. So then this is just going to be I times the square root of 6. Yes? How many answers should have I gotten in this problem? How many answers should I get? How many answers should I get? 2, right? Because what? Because it's x squared. So I should have 2 answers. How many answers do I have? 1. What am I forgetting? Why do we have to put the plus or minus in there? You don't know? Just because? Anytime that you take the square root and you're solving, you got to put plus or minus in there. Okay? So now I have 2 answers. Right? Okay? Now, let's go about this exact same problem in a different way. If I said f of x was equal to x squared plus 6, instead of saying x squared plus 6 equals 0, I'm saying f of x is equal to x squared plus 6. Based upon its degree and its leading coefficient, what does the graph of f of x look like? If I were to graph this function, f of x equals x squared plus 6, what would that graph look like?
One point would be going down, one would be going up.
Do we agree with one side going down, one side going up? Okay, well, so what's the degree? Odd or even? Even. So that tells me what? They're both going in the same direction, either up or down. I better put my bottle down before I drop it. Okay. Up or down. Lead coefficient. It's positive, so that means that they're going up. Okay? So, have you guys ever graphed a quadratic before? An x squared function? It's a rhetorical question because I know you had to all pass Algebra 2 in order to get here. So, have you graphed a quadratic before? Yes. Yeah. Faith, what shape is it? It's a U shape. Yeah, it's a parabola, right? Okay. So it's going to be an upward opening parabola, right? Now, where's the vertex going to be of this parabola? At positive 6. So it's going to be up 6 from the origin, and then it's going to be an upward opening parabola. So that's going to be the picture of it. Okay? Now, you've heard me call them zeros, solutions, roots, answers, right? But that all of those, so we call them zeros, roots, solutions, answers, whatever one of those 4 you like the best, okay? But those are the places that our function is equal to 0. Or, in another way of saying it, where our function crosses the x-axis. Oh, now he's awake. See, I couldn't even throw a marker at him because you wouldn't slide. I didn't want you to be a casualty. Move over so I can whip stuff at people that are sleeping. Okay? Alright? So my red function, where does it cross the x-axis? This red function right here, where does it cross the x-axis? So then if you're saying it crosses at 0, it would cross right there. Crossing at 6 would be over here. Where does it cross that x-axis? It doesn't, does it? It doesn't. Okay? So this function would have 0 solutions, 0 zeros, 0 roots, 0 answers. But we got to be able to solve it. Okay? That's where imaginary numbers comes in. It's for when your function doesn't cross the x-axis, but I still need to have 2 solutions because the degree is 2. Since it doesn't cross, we have to come up with some new ones. Okay? So, what I'd like you to do now is I would like you to solve this equation for me. Find me what x is equal to. Man, I hope you paused it before you went on. Okay, so what are we going to do first? What are we going to do first? Minus the 4? Can I subtract 7 instead?
You can try it.
Okay. I'm not going to try it. I'm going to do it. Okay? At the same time, what else can I do? Add 9x squared. Okay? So that gives me 12x squared equals negative 3. Now what? No. Divide by 12 first. Got to get the squared term by itself before I can square root it. Okay? So then that gives me x squared equals negative 1/4. Now what? Now we can square root both sides. Left side is going to give me x. Right side is going to give me plus or minus. What? Well, let's look at the square root of 1/4. We'll actually go the square root of negative 1/4. So we know that there's going to be an I involved, right? Because it's the square root of a negative. Right? When I'm taking the square root of a fraction, what do I do? Thinking back to your Algebra 1 days. Square root of a fraction, what do we do? Square root of a fraction, what do we do? Anybody come up with it? Not square. Square root the top and the bottom. Yep. So this is going to become I. And this is going to become the square root of 1 over the square root of 4. What's the square root of 1? 1. What's the square root of 4? 2. So this becomes plus or minus 1/2 I. That's one way of writing it, because remember the number comes first, I comes second, radicals come third, or you could write this as x equals plus or minus I over 2. Both of those say the exact same thing. And I am indifferent as to which way you write it. Huh? Because we now have I in play, we can now find all the zeros of a polynomial function. So given the fact that x minus 4 is a factor of f of x, what I'd like you to do now is I'd like you to walk me through the steps of finding all of the zeros. What would you do first? Okay, so what would you use for synthetic division? So because x minus 4 is a factor, right, then x minus 4 equals 0, so x equals 4. So 4 is a 0 then, is what you're saying, right? So then that allows me to go to synthetic division and put 4, because I put my zeros outside there. Okay, what am I going to put inside? Do I need any place holding zeros? No, because I got them all. I got started with cubed, then went to squared, then went to just x, and then went to just numbers. Okay? How do I synthetically divide? Drop the 2 down. Then multiply, gives me 8. Add them, gives me negative 1. Gives me negative 4. Gives me 6. Gives me positive 24. Which is 0. And that should be a 0 there at the end, because x minus 4 was told to me to be as a factor. Okay? Love it so far.
Then what can be written in formula as 2x minus 1x.
Hold on. F of x can be rewritten as what? No, not yet. Got to do the x minus 4 part first. Okay? Because that's still a factor. And then the other factor now is 2x squared minus x plus 6. Okay? Can 2x squared minus x plus 6 be factored? They'd have to be the same sign, right?
Yes.
Which means I'd have to add them both together. So even if I go with 1 and 6, if I add 1 and 6 together, that's 7. Not 1. If I add 2 and 3 together, which are the other factors of 6, that's going to give me 5. So since they got to be the same sign, it's not factorable. Okay? So then I say x minus 4 equals 0. So x is equal to 4. We already knew that one, though, right? Because that was the one that was given to us. Okay? Then I say 2x squared minus x plus 6 equals 0. And now somehow I've got to solve that. How am I going to solve that if it's not factorable? How am I going to solve a quadratic if it's not factorable? Quadratic formula. And remembering the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. If you did not listen to your Algebra 1 teacher and memorize that, I will reiterate what your Algebra 1 teacher, your geometry teacher, and your Algebra 2 teacher said. Memorize that. It will make your life easier if you memorize that. Okay? So going back here then, x is going to equal, negative 1 is my b, so the opposite of negative 1 is positive 1, times the square root of negative 1 squared minus 4 times a, which is 2, times c, which is 6, all over 2 times a, which is 2 times 2. Negative 1 squared. 1. 4 times 2 times 6. 4 times 2. 8 times 6. 8 times 6. 48. Two times 2. 1 minus 48. Whoa, went a little too far on that one. 1 minus 48. Negative 47. Are there any perfect square factors in negative 47? Well, because I know I is already 1, right? Okay. So are there any perfect square factors in 47? 1 goes in there, but that's not going to help us. 4 go in there? No. 9? No. 16? No. 25? 36? 49 is bigger than that, so no perfect square factors, right? So then this becomes just x equals 1 plus or minus I times the square root of 47 all over 4. Itchy nose. Okay? So, way back from the start, how many answers was I supposed to get? 3, because it's a cubic. Okay? So my 3 answers here are 4, 1 plus I times the square root of 47, all divided by 4, and 1 minus I times the square root of 47, all over 4. Those are my 3 answers. Now, if you choose to write the last 2 like this, I'm okay with that, but just know that that is 2 answers, because one of them is the plus, one of them is the minus. Okay? So there are the 3 answers that we should have got. And we can give all of them now because we have I in our toolbox. Okay? 5 total homework problems tonight. No formative assessment tomorrow. Sorry, Jenna, if I was right in the middle of your picture. Okay? All right? And this homework will be due next week, Monday, the 5th of November.